All right, starting up for problem 4, we have the model that we created in the previous one. Now, we have some changes we're going to be making. All right, we're going to be making a differently named copy of the file that we produced in problem 3, modify the features and parameters following the instructions. By the end of this process, you will submit 2 different SolidWorks files. You must follow the steps in the given order to get the desired result. The figure for this problem is available on the next page. You should not make any new features, delete any features, change any relations, or make any other unspecified changes. Only dimensions that have been changed are shown in the next drawing. So we are going to start with some renaming. Then we are going to implement 2 equations. We're going to change the order of the shell feature with respect to some of the other features on the drawing. We're going to then edit the whole wizard feature to match an updated callout. We're going to change the number of instances for the holes and the cuts, so that single pattern that we discussed earlier. And then we're going to be creating a simplified and extended configuration following the information in this table. Importantly, we do not need to make a design table. It's just given in a table because tables are just generally useful as far as organizing information. Taking a look at this, we've got our 3 different versions. We've got a couple of named dimensions and our updated hole callout. So what you would do at this point is save homework 3, then hit drop down, save as, and save as homework 4, or homework 3, problem 4. All right, so first up, renaming dimensions. And in order to rename dimensions, it's useful to be able to see them. So we're going to right click on our annotations folder and go to show feature dimensions. So maybe see dimensions is a little glib as far as ways to discuss what we just did, but you can certainly see a lot of dimensions. So let's see, we have 2 dimensions that we're going to be defining: the blade length and the insulator C, or the number of uh, these little cuts that we've got in the insulator. So the blade length is the 65 that we saw earlier. So fortunately, that one sticks out easily enough. So we've got this 65 here. You can double click on it, and then we're going to change it to blade L, which you can see then shows up there. And we have the insulator C. Effectively, what we're looking at for this, or what we're looking for in this one, is a single number 12, which is floating around somewhere. Patterns always are a bit of a pain when we're doing, or when we're trying to find the variable. Sometimes if you select the pattern itself, it'll pop out. However, it appears as though we are not going to be so lucky. So sometimes also, nope, still not showing up. Let's try doing a section. Yeah, there we go. Oh, there it is. Cool. So we've got our 12, double click on it, insulator C. Spelled probably correctly. Yes. All right. Awesome. That is step 1. Step 2 wants us to implement 2 equations. So in order to get to these, we are going to go to Tools, Equations, and then we have the hilt, which is this here, is going to be equal to the panel minus 8. So we're going to click on the Add Equations box and select the hilt, and that is going to be equal to the panel minus 8. However, generally, when you're writing equations, you may occasionally want to include units. So in this case, because it is defining a distance, we want this not only to be 8, but to be 8 millimeters. So now if the units change on the overall drawing, it's not going to be, oh, well, now it's that whatever that distance is minus 8 inches, which would definitely break something. So there we go, we've got that one. And then the other one that we want is the insulator C. So we'll select that as our second equation. And it is going to be equal to, in parentheses, insulator L minus 2 millimeters divide by 6 millimeters. So that right there, insulator L is a distance, and so we would need the 2m as the other distance, and it is divided by 6 millimeters because if these were to change to inches, we would want that to change to inches as well, so that the units would divide out, because you can't have 3 inches number of insulators, or in this case, 12 inches number of insulator cuts. You would want just 12, so a standard scalar value. Okay, so that then should give us the little sigma symbols next to our two equations. Awesome. That's step 2 down, or B, I suppose. C has us change the shell order. So there are 5 features that are going to change position on the design tree relative to the shell. So, scrolling down, let's look. Is there anything that started hollow and turns solid? And we actually do have something. We have 6 things, as a matter of fact. So looking down at the bottom with the ribs, we would want the rib to go below the shell. But in order for the rib to go below the shell, the pattern based on the rib also needs to go below the shell. So we can't drag a parent feature to be occurring in the timeline after its child features. So first we need to drag the circular pattern to go below the shell. So we can see there that then solidifies 5 of them. And to get the last one solidified, we need to drag the rib as well. Cool. So there's 2 of them. Now we look for things that used to be solid but are now hollow, or used to not be going into the inside of the shell but now are. And I kind of spoiled one of them, and that is the fillet here. So we need this fillet then to be moved to occur before the shell feature. However, this fillet is defined also based off of the top of the emitter, which is also going to end up being hollowed out. So pretty much that means that we are going to need the revolve for this top portion to go above the shell first. So we'll move that. And you'll immediately see there's a bit of a glitch going on with some of this. This is the chamfer feature, because this used to be hollow. Now when we apply the chamfer, it actually gets a little screwy. So we're going to need to move this chamfer above the shell as well. There we go. That looks a lot better. And then, now that we've moved the revolve and the chamfer, we can finally move the fillet to also be above the shell. Cool. So that was a total of 5 features that got moved. We had the ribs at the bottom, that circular pattern. We had the emitter, its related chamfer, and the fillet. So that is all 5. Cool. Next up, the hull wizard is going to need to be updated to match the new callout. Rupert, come on. Stop stepping on the keyboard. You're screwing up my PDF. There we go. Good bird. All right. Hull wizard, yes. So for this, we can see that the new hull callout has a 12x diameter 1 through hole and a diameter of 5x 120 for the countersink. So we're going to edit our hull wizard feature. We are changing this from the counter board to the countersink. Reset. We can see that it has a through hole of 1. It's got a diameter for the near side feature of 5. It's got an angle for the near side feature of 120. And the new end condition is no longer blind 5, but through. So through can mean several things. depending on the context. Uh, Usually it means through all, but taking a look at our object, we do not see holes coming out through the bottom of it. So through all probably isn't necessarily what we would be aiming for. Instead, up to next is usually a good second option. So if we can use up to next, up to surface, or through all three of those would count as a through option. So up to next, hit our check mark, and taking a look at it, this looks a lot like what we see on the drawing, which is, as always, an excellent sign. So yeah, up to next gets a little tricky when you have these sorts of bits going on. You could also use up to surface, but that should be good enough. Cool. All right, so there's our hole wizard change. Next, we want to change the instance count for the holes and the cuts in the hilt from 16 to 12. So, as I mentioned earlier, it can be a real pain to try to find instance count dimensions. So instead of trying to do that, we're just going to go straight for the pattern. So we're going to go to Circular Pattern 2, go to Edit Feature. We can change that from 16 down to 12. Cool. Nice. Very good. Alrighty. That is E. Now we have F. So that we are going to be creating some separate configurations and making some modifications to them across the different versions. There you go. All right. Whenever you've got these sorts of things, the first step is to create the extra configurations. So we're going to go over to the Configurations Manager tab over on the Property Manager on the left-hand side. And we're going to right-click on our feature, or on our part, and go to Add Configuration. So this one I'm going to call the Simplified, and then Add Configuration, Extended. And I'm just going to go left to right on this table. So the first thing that changes is the material. So we're going to go right click our cast alloy steel and go to configure material. Then at this point, we can choose the new material that we want for each one. So the first one wants chrome stainless steel, which is not one of the favorites. So we're going to go to browse more. I can type in chrome stainless steel, hit apply, close. Yep. Second one we want is nickel, which does show up. And the third one is also chrome stainless steel. Apply. We can close that, hit OK. Step up. No, you're not allowed to be a floorbird while I'm distracted. There you go. Cool. So there's our first change. Next up is the blade L, which thankfully we did label earlier, so that makes it a little easier to find. We want that to be 65 in the default and simplified, but in the extended we want it to be 300. So we're going to right click on our dimension, then we can go to configure dimension, and we can set the value we want it to have for each configuration. So for the extended, I want it to be 300, and in the other two, we'll leave it at 65 and hit OK. And since we are currently in the extended, we should see immediately the result. And if we pop back over to the simplified version, that'll be different. All right. Wait a minute, this should be... Oh, whoops. I screwed up these. Okay. So simplified, that one's nickel. Then the extended is chrome stainless steel. Browse. Apply. Close. And okay. There we go. Okay, now it's better. All right, next over, we're suppressing some stuff. So on the simplified version, we want the chamfer and the insulators to be suppressed. So our chamfer is right here. So right-click the feature, go to Configure Features, and then in simplified, I want chamfer suppressed. Hit OK. Actually, to make life a little easier, we're going to reorder these. I'm just going to drag the extended below the default and the simplified below the default. There we go. Now the tables are going to match up. All right, cool. Next up, the panel dimension is going to be 51 in the default, 55 in the simplified, and 53 in the extended. So we'll right click on that, go to configure dimension. Didn't. Oh well. So simplified is 55, extended is 53, and the default is 51. Okay, cool. So the panel got updated, and because the hilt is based on the panel, the hilt also changed. Next, we have the insulator L. Oh, whoops, we also need to suppress the insulators. So for that, we'll go to Cut Revolve, right-click, go to Configure Feature. Insulators are suppressed in the simplified. There it goes. Cool, it's looking more and more like what we're going for. Now the insulator L, that's the other thing that has changed across configurations. So for this one, it is 74 in the default, 45 in the simplified, and 80 in the extended. So we'll right-click, configure dimension. Simplified gets 45. The extended gets 80, and the default gets 74. So we'll hit our OK. You can see then that shrunk, which matches up with what we can see here. It's a little stubbier. All right. Last one is the hole and hilt count, or the hole and hilt cut count. So that's the pattern that we did before that is affecting the number of these vertical stripes and the number of hole wizard features, or hole wizards in the top. So, ooh, we got lucky. You can actually see the dimension right there. So, if we did not get lucky, we would need to go to the feature on the design tree, then we can edit, and we can choose different values for each configuration. However, that can be a bit tricky. So since we did get lucky, I'm just going to use what we have. So we'll right click on that, go to configure dimension. So for the simplified version, we want 6 of them. For the extended, we want 16, and for the default, we'll leave it at 12. So that got a little simpler, that got a little simpler, and that should be all of the changes. Last thing you want to do before you submit anything is always double check to make sure that the configurations did what you expected them to. And in this case, we can also double check masses. So we'll go to our default, which looks pretty similar. So then we can go to mass properties, and we can see 973.91, 973.91. So that's right. Now we'll go to simplified mass properties, 1068.62, 1068.62, nice. And lastly, we'll go to extended, check our mass properties, 1586.11, 1586.11. Awesome. Save this, make sure the naming convention matches with what it's supposed to, and we are good to go. So I'll cut the recording here and see y'all again on homework 4.